So in the last lecture, we saw how sleep and wake system call eliminated the problem of busy waiting. But in the producer consumer problem, we saw one thing, that even with sleep and wake system call, there was a problem. The problem was that sometimes the wake system calls were getting wasted. When the producer was invoking the wake system call to the consumer, actually when the consumer was not sleeping. So on that time, the wake system call was getting wasted. So in order to overcome this problem, Dijkstra in 1965, he introduced semaphore variable concept. Okay. So, here basically what happens is that semaphore is an integer variable. So here you see basically what happens. Initially, here producer and consumer. So producer was directly invoking the wake system call to the consumer, and this wake system call was getting wasted when the consumer was not sleeping. Okay, so what Dijkstra did, in order to solve this problem, Dijkstra introduced one semaphore variable, SV. Okay, so it is an integer, so it holds the integer value. So here, what value it will hold? It will hold the number of wake up calls. So here, rather than directly invoking the wake system call to the consumer, here producer should send this wake system calls in the semaphore variables. Okay, here suppose producer has sent the wake call to the semaphore variable, and now the semaphore variable is 1. It means what? The producer has sent one wake call. Okay, so this semaphore variable can be used by the consumer at later point of time. Okay, suppose now the consumer is not sleeping, consumer is busy with some other activities. So after finishing the activity, if the consumer gets tired, after finishing that activity, if the consumer wants to sleep, okay, so before sleeping, the code will be written in such a way that before sleeping, the consumer will check this semaphore variable. Okay, and if the semaphore variable has some positive number, okay, like 1, then consumer will come to know that one wake call has been invoked by the producer. It means what? Consumer will come to know that someone might have tried to wake him up. So now, after accessing this variable, consumer will not sleep. Okay, so it's a semaphore concept. So here more than one suppose 2 or 3 wake calls can also be there. So on the basis of that, the integer will change. Suppose if producer would have sent 3 wake calls, then the semaphore variable would have contained the value 3. Okay, so don't worry, I will discuss about all these things. So now you see this. So in this way, the wake system calls are not getting wasted, because these wake system calls are stored in the semaphore variable, which is later used by the consumer. Okay, so here you see one important point, that this semaphore variable is a shared variable which is shared by both consumer and the producer. Okay, it means what? It is shared by multiple processes. So just remember from the first lecture of process synchronization what I told you, that remember the case of count variable. When count variable was shared between the two processes P1 and P2, and it was shared simultaneously, then the data inconsistency problem arise. Okay, so in order to solve that problem, atomicity concept came. Okay, so here also the same thing will happen. Since it is a shared variable, so if both producer and consumer will access this variable at the same time, then there will be some inconsistency. It's better that both write and read operations should happen in an atomic manner. I mean to say that when producer is writing something in this semaphore variable, suppose when producer is sending the wake call to the semaphore variable, for example, 2 wake calls, okay, 1, then again 1 plus 1, 2. So during this time, the consumer should not access the semaphore variable. Okay. Once the producer has completely written this semaphore variable, after that, only after that, consumer will come and consume it. Okay. So this write operation by the producer and read operation by the consumer will happen in an atomic manner. It will happen atomically. So since here atomicity is required, so semaphore needs the support of the operating system. Okay. With the help of the operating system, this atomicity can be achieved. Okay. Although it will be used, semaphore is used in a user mode, but it will implemented in a kernel mode with the help of the operating system. That's why I have written semaphore is a variable where read write happens atomically in kernel mode. Okay. And the second statement is that there are 2 types of semaphore: counting semaphore and binary semaphore. So binary semaphore is also known as mutex. Fine. So in order to achieve mutual exclusion, we use binary semaphore. Binary semaphore, it uses just binary values, that is 0 or 1. Okay. So here what happens, mutual exclusion is there. I mean to say that if one process is inside the critical section, then other process can't enter in it. Okay. And in counting semaphore, what happens, sometimes we want more than one process to access the critical section simultaneously. So for that, we use counting semaphore. Okay. So let's get into the detail of this counting semaphore in the next lecture. Thank you.